Good morning. I am Saranya, Assistant Professor of CSC, Adiyaman College of Engineering. So, I am taking the subject Theory of Computation. So, in that theory of computation, we have first go to introduction. So, in that introduction, in theoretical computer science, the theory of computation is the branch that deals with whether and how efficiently problems can be solved on a model of computation using an algorithm. And this field is divided into three major branches. One is automata theory, and second one is computability theory, and third one is computational complexity theory. In order to perform a rigorous study of computation, computer scientists work with a mathematical abstraction of computers called a model of computation. So it is to be mathematical abstraction of computers. It is called a model of computation. So next, this automation consists of the states, transitions, and also the input. The states are represented by the figure by circles, and the transition is represented by arrows. And then automation sees a symbol of input. It makes a transition to, it will be jump to another state. It will be transition or jump to another state, one state to another state, according to its transition function, which makes the current state and the recent symbol of it inputs. And uses of automata is using compiler design and parsing also. So next we go to languages. So the languages we consider for our discussion is an abstraction of natural languages. That is, to focus here is on formal languages that need precise and formal definitions. So programming languages belong to this categories. They are symbols, alphabets, and also the inputs, etc. So we go to the languages. So the languages belongs to this category. It is comes under symbols, alphabets, etc. So the symbols are indivisible objects or entity that cannot be defined, and the symbols are the atoms of the world of languages. A symbol is any single objects. It consists of a, 0, 1, hash, or anything. So next we come to alphabets. So an alphabet is a finite non-empty set of symbols. The alphabet of a language is normally denoted by when more than one alphabets are considered for discussion. So the subscripts may also be used. Sometimes other symbols like G may also be continued. So in that alphabets, it contains set of symbols, and then symbols are the individual objects such as A, 0, 1, or it can be anything or behind. So next we go to the finite automata types. So in the finite automata there are two types. For example, it is this is a finite automata. There are two types. First one is deterministic finite automata, and second one is non-deterministic finite automata. So we go to deterministic finite automata. In the deterministic finite automata, they are a simple machine that reads an input string, one symbol at a time, and then after the input has been completely read and it will decides. So it means the deterministic finite automata means only one symbol, only one state can be reached. So the input can be zeros or ones. So in that deterministic finite automata, informally it is a simple machine so that reads a input string. So that one symbol at a time, and then after the input has been completely read and it will be decides whether to accept or reject the input. As the symbol are read from the tape, the automation can change its state to reflect how it reacts to what it has seen so far. And then a machine for which a deterministic code can be formulated and if there is only one unique way to formulate the code. And then this machine is called as the deterministic finite automata. So for example, in that finite automata means it is used to elevator. So elevator and also the chessboard is example for non-deterministic finite automata. So elevator means it will goes to only one state. We have to put. If you have to decide the floor 1 means it will goes to only one state. So that is example for elevator is example for deterministic finite automata. So next we go to non-deterministic finite automata. So non-deterministic finite automata is an important abstraction in computer science. So the importance of non-determinism is found is in the design of algorithms. Design of algorithms. So for example, there are many problems with efficient non-deterministic solutions but no known efficient deterministic solutions. So in that we using traveling salesman algorithm, Hamiltonian cycle, click, etc. So for example, non-deterministic automata is an important abstraction in the computer science. So it is very important for to moving the one state to another state. So it will also consist of states, transitions, input symbols, etc. Already I told the inputs are the represented by circles, and also the transition are represented from one state to another state, and then the input symbols can be an 0, 1s, A, B or any other, etc. So in non-deterministic example is traveling salesman algorithm, Hamiltonian cycle, click, etc. And the behavior of process in a distributed system is also a good example of non-deterministic situation. So the behavior of processes in distributed system means it will be distributed from one system, one state to another state, and then or one state to multiple state are also carried out here. So behavior of processes in the distributed system. So it's a good example for non-deterministic situation. So because of the behavior of process might depend on some messages from other processes that might arrive at arbitrary times with arbitrary contents. So a good example of non-deterministic finite automata is chessboard. So in that chessboard we can move either multiple states from one state to multiple state. Every state it will be begins and every state it will be end. So the main thing, deterministic finite automata example is for an elevator, and then non-deterministic finite automata example is a just chessboard. So it is a good example for non-deterministic finite automata is traveling salesman algorithm and then Hamiltonian cycle, click, etc. because it uses one state to multiple states. So it is a good example for non-deterministic automata. In both deterministic and non-deterministic finite automata, they are using the states, transition, etc. So and then input symbols also. The both deterministic and non-deterministic, the input symbols are maybe either 0, 1, A, B, C, any alphabets that can be shown in that symbols. No. So alphabet is a finite non-empty set of symbols. So the alphabet, it can be defined as the one alphabet are considered for discussion, and then subscript may also be used. Sometimes other symbols like G may also be used. G means it will be represented as graph here. So it symbols means it is an indivisible object. So already I told. Languages that belongs to it is an abstraction of the natural languages. So finally we conclude. So it is it is an NFA and DFA for the given regular languages also. It is easy to construct. The concept of NFA can also be used in proving many theorems and results. So it plays an important role in this subject. So we have to conclude. Thank you.